All right, hey everyone, I'm Matt, and I'm here to talk about how we can use all the cool Swift Android SDK stuff that we've been working on to actually call Swift from Java. So just a quick introduction, I work as tech lead at Frameo in Denmark. I most importantly probably worked on the Swift Java project last summer as a part of Google Summer of Code. I worked on adding the J&I mode. So just to give you a broad background about Frameo, that's the company I work for. We're producing software for digital photo frames. We have three main platforms. We have the client apps that send photos to your photo frames. So that's an iOS app and an Android app. And then we have the frame software, which is basically running on a fancy, or not so fancy, Android tablet. So just to give you an idea of the numbers that we're working with, we have over 20 million downloads. We have over 2.2 billion photos that has been sent across our systems. And most importantly for this talk probably, we have 17.5 million Android devices. So that is shared across both, as I said, the client apps, so the actual phone sending the photos, but we also have the frames, which are also running Android natively. So for us, as you can imagine, when we're building new features, we often have to write multiple implementations, one in Swift, one in Java. That's quite a bit of, that's not so nice for time, and we most often need a lot more Android developers than we need Swift developers. So at Frameo, traditionally when you want to send a photo to a photo frame, the frame and the client needs to be online at the same time. That's kind of an issue when you're sending across Atlantic, for example, somebody's sleeping and the frame is offline. So we wanted to build a new feature where you can send photos to the cloud and the frame can fetch them when they come back online, right? So we decided to build a library for this. It's called Chia. And it's basically a Swift library that handles all the media transmission between the photo frame and the client. And it implements a signal-like protocol. So if words like double ratchet encryption mean something to you, that's what we're doing here. So this library runs or basically handles everything that's related to this. That means both encryption, networking, storage, and even more. So this library is used across both our iOS app, our Android client, and the frame. So, since it's a Swift package, the split is quite traditional. We have one main app target that's called Chia. And we have a few different helper targets underneath, like the double ratchet encryption, different message like server clients, and the protobuf layer. And then what's most important about this is that we're able to utilize the entire Swift ecosystem, or a lot of it actually. We are using stuff like Swift logging, Swift async algorithms, Swift collections, Swift async HTTP client, Swift protobuf, Swift Neo, Swift Open API generator, and they all just work across both Android and iOS. So how do you interact with this library? Well, it has one main type. It's called Chia client. It has a few different main important methods. You can encrypt some messages. You can request upload URL to the server. You can encrypt some media from a file at this system, stream it to another file. And you can at the end also download something from the server and decrypt it streaming while you can. That's quite important for us because these frames are very low on hardware, so they don't have a lot of memory. So we can just load the entire thing into memory. And we're able to use the file system from Swift Neo to just do that across all of the free platforms. So how do you initialize such a client? You have to provide it with an ID. You need to provide it with a private key. And there, most importantly, there's these two protocols. There's the Chia storage and the message handler. Now, the double ratchet encryption algorithm requires persisting some state about the sessions. So that's really up to the platform that you're running on. On the iOS, we use Core Data. On Android, we could use Realm, or like the file system. So that's quite a common thing in Swift that we reach for a protocol to create this abstraction. The same goes for the message handler, which is notified when the server tells the client that there's new messages for it to fetch. So that's kind of great, right? For Swift, we have a working library in Swift. We can use it on iOS. And I go to my boss and I say, hey, I'm done with Swift now. And he goes, oh, well, we need it on Android as well, right? Oh, I have to go tell my Android developers we need to do it all again, just in Java. Or we can use Swift Java. So the cool thing is that Swift Java comes with a tool that's called JExtract. It is basically a source generator. It analyzes your Swift files, produces Java files for you. Or analyzes your Swift files, produces Java files, and it basically allows you to call Swift directly from Java. And what made this possible on Android is the J&I mode that I worked on at the Google Summer of Code last year, along with Conrad. And we've been extending it ever since. And if you want to get a bit more in detail, I suggest you watch the talk from Server-Side Swift last year. I go a bit more in depth into the nitty-gritty details. So there are 3 steps to using this to wrap our library on Android? It's quite simple, actually. The first step is we need to add a config file to our Swift project. Then we can apply the build plugin. And then at last, we need to build an Android package that we can send to our Android developers. So let me take you through that steps. The config file is pretty simple. It tells Swift Java how to wrap the Swift target for use in Java. So you can tell it what's the Java package name, what mode do you want to use, and you can provide additional configs. The second part, most importantly, is actually adding the build plugin to the package.swift file. This is what will, at build time, analyze your Swift files and generate the Java sources automatically for you. The way we did this is that we define a variable in package.swift, which is the nice thing that it's a Swift file. So we conditionally choose whether to run the Swift Java build process or just do it as we always, because we need to, for example, to be a dynamic target when we're building for Android. And then, of course, we also need to add the Swift Java dependency, add the targets, and then, in the end, add the build plugin. And the last part is that we need to bundle all of this up into an Android package that we can tell our Android developers they can fetch from something like Nexus. The way that we did this is that we created a subdirectory in our Swift project called Android, and it's basically just an empty Gradle project. And it's based on the Gradle files in the Swift Android examples repo, which is open source. And what it basically does is that it calls Swift build, as you saw in Mark's talk, with the Swift Android SDK. And then it finds all the needed SO files, the generated Java files, and packages that all up into an Android package that we can send over to our Android developers so that they can use. And all of this is running in CI, so it's really great for us. All right, so now we have imported our library into Kotlin in this. So yeah, even though it's Swift Java, Java and Kotlin has interoperability, so we can even use it in Kotlin. So we're able to instantiate a Chia client, we can instantiate an ID, and you see these two protocols I was talking about earlier. So in Swift, those were protocols. How do we pass something back to Swift when we're in Kotlin? Well, if we look at the extracted sources, we see that actually it's introduced as a generic. And these types actually become interfaces in Java. So that means that our Kotlin developers can write their own implementations, saving it in something like Realm or the file system on Android, and being able to use their APIs that they know, and we're not forced to write something in Swift. So we can pass that back to Swift, and Swift will call that when it needs to. What about Swift Concurrency, right? If you've ever written a Swift library nowadays, you're probably using async await, and so are we. So we have this fetch function, which is the way that the client fetches messages from the server. That's async await. How does that get converted? Well, a new feature we've added is that it gets converted into a Java future, which is sort of the go-to concurrency type on Java. So that provides an API that Java developers are also familiar with. So just to show you how similar the code actually is, I've written a small implementation of the message handler in Swift. And here's the corresponding Kotlin implementation using the same exact Swift library underneath. And because of types like enum that get bridged properly, we're able to get exhaustive switching over enums. We're able to call async await methods. We're able to stream directly to the disk, all because of these Swift packages just working coherently across the ecosystem. Now, you've probably also written a bunch of cool documentation for your functions, or you should probably. Now, what happens when we get that, when we convert that? Well, a new feature we've also added is that it actually gets converted to JavaDoc, so your Java developers also get the awesome documentation that you've written for Swift. Yeah, that's pretty cool. So I've basically built a library for 2 platforms without even knowing it. I only need to apply these 3 steps, and then it worked automatically. So this is all thanks to Swift Java, and it's very much in particular thanks to new features we've added, like async await support, nested types, arrays, and then most importantly, probably implementing protocols in Java and passing back to Swift. So what I want you to take away from this talk is that I wanted you to see how low effort you can actually get, or you need, to wrap your Swift libraries and use it cross-platform. You share your business logic, and it saves time and frees up a lot of resources. We don't need to allocate a lot of Android development time. We can just allocate my time as a Swift developer instead. And we're still able to utilize Swift strengths like protocols, enums, async await, the Swift package ecosystem, but still extracted as a very, very nice Idiomatic API that Java developers know and are used to talking with. Yeah, that was it. Thank you.